Hello everyone, I am Shubham Jaishri Sridhar Pawar. Welcome back to my channel. In today's video, we are going to start a new ETABS tutorial series. I will show you step by step how to model, analyze and design G+4 RCC building in ETABS. In the first part, we will try to cover the complete modeling, and in the second part, we will move to the analysis and design checks. So I request you to stay tuned of the video and the series till the end. And please don't forget to subscribe, like and share for more interesting and useful videos like this. In this course, you will learn a complete analysis of RCC structure using ETABS software, use of Indian standard codes, important aspects in civil, structural and earthquake engineering. Now as we come to the next slide, these are the important Indian standard codes, IS codes we are going to use for analysis and design purpose in software. So IS 456-2000 code of practice for plain reinforced concrete. This is the general code of practice for RCC structure. Then IS 875 Part 1 1987. This is for the code of practice for dead loads. Then IS 875 Part 2 1987 for imposed load, that is live loads. Then IS 875 Part 3 2015 for wind loads. IS 875 Part 5 for special loads and load combinations. See, we are not using IS 875 Part 4 because the IS 875 Part 4 is for snow loads and we are not taking the location near the snow, so we are neglecting the code IS 875 Part 4. Now, IS 1893-2016, this is the earthquake resistant design code. Then IS 13920-2016, which is ductile designing, detailing and reinforced concrete structure for seismic forces code. This is the detailing code. So now let's note down the key information of the structure. The information we are assuming, the technical information. So type of structure is multi-story rigid jointed frame. So this means we are using a reinforced concrete frame system where beams and columns are rigidly connected. Number of floors are G+4. Then floor to floor height we are taking 3 meter. This is quite standard height for residential and commercial buildings. Then plinth level. Plinth level we are taking 1.3 meter. This is the height of the ground floor from the foundation level. Ground floor means the plinth level height above the ground from foundation level. Now location of the structure I am taking Nasik, Maharashtra, which is urban region. The reason I am mentioning the location of the structure is because this information later will be useful while defining the seismic and wind parameters of the structure in ETABS. So this is our architectural plus structural plan. As we can see, architectural rooms and their respective sizes are mentioned. Then there is the framing. The framing is also seen. This is the structural framing, as the green color defines the beam, the magenta color defines the rectangular columns, then hidden beams is also shown. Hidden beam is also shown with the cyan color. If you want, the audience or the engineers who are watching the video wants to learn the structural framing or column orientation, then I can also make a separate video on it. This is the grid plan. This plan is required for setting up the grid lines in ETABS. I will show you when we open the software that how to set the grids. See, these grid lines are the most important part in the ETABS because the structure is mainly modeled on the grid lines. So if you want, the engineers watching the video want that how to make the grid lines or grid plan, then I will also make a separate video on it. So before moving to the software, we have to mention or decide the preliminary dimensions or preliminary sizes of the structural members, that is the beams, columns, then slab. We have to assume, but we have to assume it technically. So we are using some important clauses from the IS codes for designing, also for mentioning the preliminaries or deciding the preliminary dimensions of the structure or beams, columns, slabs. So firstly, we are deciding the preliminary sizes of the beam. So preliminary dimension of beam is, I am deciding it based on the two clauses. So clause 6 of IS 13920-2016 and clause 23 of IS 456-2000. So first we take the part A, that is the clause 23.2 of IS 456-2000. So as we move to IS code, IS 456 2000, clause number 23. So this is the clause we are using for the preliminary dimension of the beams. This clause number 23.2.1a, where the basic values of span to effective depth ratios for spans up to 10 meter are mentioned. So as we move to the structural plan, we are considering we are considering the longest beam of our structural plan, which is around 5.6 meter, 5.6 meter, and according to IS code, the beam is continuous. So we are considering 26, the value for the basic value of span to effective depth ratio as 26. So now the preliminary sizes, the what it means that span to the basic values given as 26. So this means that the length, that is the effective length or the length of the beam to effective depth is equal to 26. So we are considering L is equal to 5600, which is 5.6 meter. Then from the calculation, we get effective depth is equal to 216 meter. And if we add cover, that is the cover for beam, we use 25 mm. So 25 mm on the both side, which is equal to 50 mm. So if we add 50 mm to 216 mm, we get overall depth is equal to 70 meter, 270 meter. Sorry, 270 mm. So firstly, we consider the B part. Later, we will decide if we want to take this depth, overall depth or not of the beam. But first, we consider the clause 6 of IS, clause 6 of IS 13920 2016. So as we have come to IS 13920 2016, this is the clause 6 we are using for deciding the preliminary sizes of the beam. This is these are the points which we will consider. I have written it. So I have written, yes, I have written the points that beam shall not have width to depth ratio of more than 0.3. Then second point is beam shall not have width less than 200 mm. Then beams shall not have depth more than 1 by 4 of clear span. So firstly, we are assuming the width. So width I am assuming is 230 mm, which is quite standard size of width for beam. So our first, the second point, that beam shall not have width less than 200 mm is satisfied. Then see, beam should be a proper rectangular cross section, and as from the codal provision, we get overall depth as just 270 mm, which is I think quite small. So as the structural consideration or general practice for the structural engineer practice, we, according to thumb rule, or we can say according to our practice, we consider that length or effective length to effective depth ratio should be between 15 or L by D should be 10. So this is the general practice of structural engineer as safety is concerned for the structural members. So as this increase the size of the, as this will increase the depth of the beam. So for general practice, beam is the depth of the beam is calculated using this formula. So we are considering L by D ratio is equal to 15. So from that we get effective depth is equal to 380 mm, and by adding the 50 mm to it, we get overall depth is equal to 430 mm. So preliminary beam size or preliminary beam section, we get 230 into 450 mm. See, I am considering this size for all the beams. Means for primary plus secondary beam, I am considering 230 by 450 mm size. So now we have to satisfy that first point, that beam shall not have width to depth ratio of more than 0.3. So if we consider B by D, so 230 by 450, which is 0.511, which is greater than 0.3. So are all the three are satisfied. Okay, the point 3, that beam shall not have depth more than 1 by 4 of clear span. So if we consider the clear span, that is 5.6 meter, that is 5600 meter, and if we calculate that at overall depth is 450, so as the clause is mentioned that beam shall not have depth, overall depth more than 1 by 4 of clear span. So 450, no, sorry, 5600 divided by 4. Okay, so it comes to 1.4 meter. So our depth which is overall depth, is 450 mm. So all the 3 points of clause number 6 of IS 13920:2016 are satisfied. Now we come to the preliminary dimensions of column. So as we have decided the preliminary dimension of the beams, we are also deciding the preliminary dimension of columns according to IS 13920:2016. Here we are using clause 7.1. So if we go to clause 7. So this is IS 13920:2016, and this is the clause which for column dimension we are for deciding the column preliminary dimension. I have written it in the PPT. So as column 7.71, the minimum dimension of column shall not be less than 20 dB, where dB is the diameter of the largest longitudinal reinforcement in beam. The second point is that minimum dimension should not be less than 300 mm, and the cross-section aspect ratio, that is ratio of smaller dimension to the larger dimension of cross-section, shall not be less than 0.45. So I'm considering that for clause, if we see clause number 7.1.1, if we have to decide the minimum dimension, 20 dB. So here dB, where the diameter of the largest longitudinal reinforcement bar in the beam passing through or anchoring into the column at the joint. This means if there is a beam resting on a column, the beam passing through means the beam is continuous or anchoring in the column that is simply supported, then we have to consider the largest diameter of bar we are assuming to use in the detailing of the beam. So I'm assuming that the largest diameter of bar we are going to use is 16 mm. So 20 dB means 16 mm, 20 into 16, which is 128, 332 or 320 mm. So from all the three things of the clause 7.1 of IS 13920:2016, considering the preliminary size of the column, all columns I am considering as 380 into 600 mm. Here, if we consider the aspect ratio, we get 0.633, which is greater than 0.45, which is okay. Now, I'm assuming the preliminary slab size of both general slab and the west slab to be 150 mm. Then from the slab size, we are considering the size or assuming the size of hidden beam to be 230 into 150 mm. Now, if we write the summary of the preliminary size, we are considering the preliminary sizes of the beam to be 230 into 450 mm, which is secondary plus primary beams. I'm considering the both. Then preliminary sizes of hidden beam, which is 230 into 150 mm. Then preliminary size of columns, as we have calculated is or decided, is 380 into 600 mm, and preliminary size of slab assume is equal to 150 mm. I am assuming preliminary size of slab for both west slab and general slab. Now, considering or assuming FCK, which is the character strength of concrete or the grade of concrete, to be 25 MPa, and Fy, which is the yield stress of or grade of steel, to be 500 MPa for the material properties of to mention in ETABS. Now, so as preliminary data is decided, so this before going to the software directly, these are the general steps we are going to follow. So first step is to enter the basic data. The basic data include grid data, story data, input data, and we have to set the units. Then we have to define the material properties, then define the section properties of columns, beams, slabs. Then we have to define the diaphragms, then draw the structure, then assign the conditions to the model. The conditions include support conditions, releases to the beam, diaphragms. Then we have to check the model, load calculations, define the load patterns, load cases, mass source, then assign the loads, then define the load combinations, then analysis the structure, and then design the structure. So now we have already completed the data which is required for ETABS modeling, the steps which we are going to follow in the chronological order as mentioned here. So now I am directly moving to the software ETABS. So let's start. So as you can see, I have opened the software. This is the user interface of the software ETABS. These are the tabs, file, edit. These are the options which we are going to use, the toolbars. See, these are not available currently because we have not started yet the new model. So I have clicking here in the file, then new model. We have to use built-in settings suite. So we have to select the units as metric SI, then region for default materials as India, then steel section database as Indian. Then the steel design code we use in India is IS 800:2007 for limit state of design. Then for concrete design code we use IS 456:2000 for limit state of design. Now I'm clicking here for OK. Now here comes, this is the new model quick template, means this is the grid dimension, and here comes in picture the grid plan which we have drawn. So this is uniform grid spacing. Here the grid lines will be drawn or modeled. So this is the uniform grids, but the grids in our plan are not uniform. So I'm clicking here on custom grid spacing. Then I'm going to edit the grid data. Now here are the two options: display grid data as ordinates and display grid spacing as display grid data as spacing. Now as we can see from our plan is the grid data is not as ordinate, because if we consider the grid data as ordinate, here you can see that the first ordinate is 0. Then that is, we have to start from the point somewhere from the 0, and then we have to take it as a reference point, and we have to add from that point. If we consider, see, as we can see from this data here, we have to consider display grid data as spacing, as we have mentioned the individual spacing here. This is the x-axis and this is the y-axis. So this is the x-axis and this is the y-axis. ETABS also use the similar pattern, that is x-axis and y-axis, and z-axis is used as for the up or the height. So now as display grid data spacing, the spacings or the spacing is already mentioned, the dimensions of the mentioned. I'm just putting the dimensions here. So as we can see, we have to add 1. See, this is the x-axis and this is the y-axis. So 1. So x grid data we will have 1, then 1.95, then 1.49, then 0.95, then add, then 0.49, 1.49, 0.95, then 1.26. Okay, now add 1.26, then 0.77, then 1.443. Okay, so these are the grid data in x direction. The perpendicular lines are drawn, you can see here. Yes, we are considering bubble size as 500 standard size. Okay, now y direction, the y grid data. This is the y grid data from here. Okay, so 3.20 from bottom. So 1.32, then 1.27, then yes, we have to add, then 1.38, then 1.23. Okay, then 1.30, then 2.32, then 1. Okay, 2.32, 1.30, 1.23, 1. Okay, so our grid data has done actually. Okay, the grid data is, as we have completed the custom grid spacing data. Now we are moving to the story dimensions, the simple story data. So number of stories. So number of stories we have considered is ground floor plus 4 floors. We are analyzing G+4 building. Then one again for terrace floor and headroom. So total number of stories are 7. The typical story height is 3 meter, which is already mentioned, so not a problem. Then bottom story height. So bottom story height, as we can see, the plinth level height. It is the plinth level height, which is 1.3 meter. So here for bottom story, we have to write 1.3 meter. Okay. Now, okay, after that we have to move to custom grid story. So here, as I have write 7 stories, I'm here just giving the names to the particular respective stories. So ground floor, then first floor, then second floor, then the third floor, then the fourth floor, then the terrace floor, and last is the headroom. Okay, so click OK, grid only. Okay, so okay. So as the grid data is completed, now we have to follow the chronological steps. So unit steps: enter basic data, grid data, story data, and input data. So we have set grid data, story data, input data. Now we have to check the units. So here on the right side is a unit. So we have to show the unit form. Here we have to check the length, which is in mm. Okay, then force, which is in kilonewton. So units are checked. So now let's go into the step 2. We are defining the material properties. So here I request all the engineers who are watching this video from here, please pay attention. So here we go to define material properties. Here ETABS already have given some material properties, but which is M30 or HYST F415, but we are not using the steel grade and concrete grade as given mentioned. So here I go to the add new material region. I select India, material type concrete. Okay, as I am selecting material type concrete because as I am selecting 25 grade concrete, so standard Indian and grade M25. Okay, here we have to see the material name M25, material type is concrete, isotropic is okay. Here we don't have to change anything. Okay, we just have to check the modify show material property design data where the grade is mentioned M25 and concrete cube compressive strength is 25, which is perfectly fine. So okay, so our material is added. Now we have to add the grade of steel. So here grade of steel is add new material, region is India. Now material type. So for grade of steel, we don't have to use the material type as steel, as it is not the typical steel sections, or which we can say the I sections or channel sections. Here the reinforcement is denoted by the rebar. So here material type will be rebar. Now standard is Indian. Okay, great. So grade is already there. We are using the grade FY 500. Okay, so grade is 500. Okay. Now here, so material name is HYST 500. Material type rebar. Material property, okay, 500. So click OK. Okay. So grid data is set. Story data is set. Okay, so I am going to view, set plan view, ground floor. Okay, this is my ground floor. Now, so our second step is also completed. Now, as I go to define the section properties, we have to define the section properties. So section properties, we have decided a preliminary size for beam as 230 by 450, then preliminary size for hidden beam is 230 by 150, preliminary size of columns is equal to 380 into 600, and preliminary size of slab, including the waist slab, is 150. So as defining the section properties, define section properties, frame sections. Okay, here already the some properties are given, but we have to go to the add new property, concrete. Okay, so now M13. So okay, first I will select the column property, column C. We are choosing the 380 by 600 column. So 380 by 600 column. Material is M25. Then okay, modify show, no, auto. Then concrete rectangular. Okay, depth. So here depth is 600 mm and width is 380 mm. So as we have completed the depth and width dimensions, now before clicking on OK, we have to go to property modifiers. So here here we have to consider or give some property modifiers according to IS 1893-2016. So see, so according to clause 6.4.3.1, for structural analysis, the moment of inertia shall be taken as, so in RC and masonry structures, 70% of moment of inertia of columns and 35% of moment of inertia of beams. So as we are defining the section property of column, so we are giving 70%, that is 0.7 of moment of inertia. Okay. Now reinforcement. Reinforcement we are designing as column. So here longitudinal bars, HYST 500, confinement bars also HYST 500. Then rectangular, okay. Reinforcement to be designed is okay. Clear cover 40 mm. Okay. So rest of the things will be okay. Okay, modify, okay. Column. Now column is given, so I am clicking on OK. So we can delete multiple properties. I am deleting it, except okay, delete section, delete, delete. Okay. Now as the column is given, now I am going to define beams. So concrete again. Here the beam section is 230 by 450. So beam 230 by 450. The M25. Oh, sorry, M25. Then depth is 450 and 230. Okay, now here property modifier according to the IS code 35% B. So the moment of inertia is 0.35. and 0.35 for beam. And here we have to select M3 design only beam. Now the longitudinal bars 500, 500. Okay, now your cover, we have to select cover to longitudinal rebar group center 25. Okay, 25. Okay. So section properties of column and beam as okay. Now hidden beam. So now I'm not adding new to the property. I'm just selecting here add copy of the property, because rest of the things for the beam will be same. Here I'm just giving the name hidden beam. Hidden beam is of 230 by 150, 230 by 150 mm. Here depth is 150 mm and width is same. Modifier properties we have to not change, then modify. Okay, rest of the things are the same. Mhm. Okay, so now beam and column section properties are given or defined. So here I click OK. Now I have to define section properties of slab section. So ETABS has also given some of the slab section. Okay, delete the property. Okay, now add new property. We have considering slab of 150 mm, M25. Here we have to select modeling type as shell thin only. The reason we consider model type as shell thin because the slab is a thin element. Now, yes, now we have to go to thickness. Thickness is 150 mm. Okay, modify show here, no modifiers. Okay, so okay, delete. Okay, the slab 150 mm is for both. That is for waist slab plus the normal slabs. Okay, so now we have defined the section properties. So as we go to the PDF, sorry, PPT. So the third step is means this third step is completed. Now we have to define the diaphragms. So basically, what is a diaphragm? So basically, diaphragm is used to transfer the seismic and wind load to the vertical members. That is, the slab distributes the horizontal force equally to all the columns or the shear walls through the diaphragms. So we use diaphragms for a particular floor in ETABS. So here I go to define, then diaphragms. So we are adding diaphragm to all the floors, which includes the slabs. So here add new diaphragm. We are using the rigid diaphragm. So first floor, okay, add new diaphragm. Second floor, then add new diaphragm. Third floor, then fourth floor, then fifth, oh sorry, no, fourth floor, then terrace floor, then headroom. Okay, so diaphragm is considered where the slabs are drawn or model. So okay, deleting the diaphragm, delete first, second, third, fourth, headroom and terrace. Okay, so now our fourth step is completed. So now we have to draw the structure. Okay, so to drawing. Okay, grid plan, structural plan, structural plan. So the first we are drawing the columns. So go to draw beam column press objects, then go to quick draw columns. Quick draw columns. So here the column size is already mentioned. Here according to grid plan. So 1 meter, 1 meter. So this column has the horizontal rotation. I want to make vertical. So here angle. So here angle I am giving 90 degree. So the column, okay, so column will be here. Okay. One thing I forgetting undo. Here, as the columns are for all the stories, I am selecting here all story option. Now, so drawing here all the columns. Column, okay, column one and column 1.49, 1.49. So column two here, then column number three. Okay, column number three. Then column number four, column number four. Then column the angle. Now I have to consider angle 0. angle. Okay, so here column number 4 5 1.3. Okay, column number 5. Now consider angle 90 again. We can change the angle to any degree according to column's line section. So here column, okay, here the column. Now here 0.77 this column. Okay, here the column. Now okay, so now again the orientation is changed 0 degree. So here will be the column. Okay, now after this column, okay, then here will be the column. And okay, again the orientation is changed 90 degree. So yeah, here is the column. Now okay. In this line the column is present. Okay, so here I think the grid lines are not given, so I forget to add the grid lines. We can add the grid lines. So now escape. So now let's minimize. See, so now we can add the grid lines here for 1 meter from bottom. So I go to the edit storage data, sorry, edit, then edit storage grid systems, edit storage grid system. Now go to modify show grid systems. Here, as we have to add grid lines from 1 meter from the y-axis. So here for 0, here I add grid as spacing, display grid as spacing. So I am here adding, no, sorry. So here I am adding display grid as ordinate only. So add, here I am mentioning 1 point, no, only 1 meter. Okay, so here okay, here I'm going to refresh view. So as you can see, the grid line at 1 meter has been added here for the column positioning. So refresh view. Okay, so now I can add the column here. So go to draw beam column race, quick draw columns. See the orientation now. So orientation is same. So I'm drawing here the orientation, the columns. Okay, 1, then at this part 2, then at this part 3. Okay, so as we can see, all the column positioning and orientation has been covered according to the grid plan. Okay, so let's go to the 3D view, new window. See, as you can see, the columns are being placed at all stories. So here we go to extruded view. See, now after the columns we have to add the beams. Okay, so now we have to model the beams. So first we have only two sizes of beam. The first is the 230 by 450 and the second one is hidden beam, which is I think 230 by 150. So I go to then draw. Yeah, we have to select the first option, draw beam column and brace plan 3D elevation. So okay, now okay, so yeah, okay, it's okay, all stories, no problem. So I'm clicking here, this point to this, no, this is the hidden beam, this point to this, and this point to this. No, here is no beam, here is no beam. So the framing, see the framing, you can see the framing. Just we have to just add the grid to grid points for the framing. Okay, so grid points. Okay, okay, okay. So no, here is no grid point. See, as you can see, I have selected all story option only, so no problem. So grid point, okay. See, grid point. Okay, so this point here. Okay, this is the secondary beam. Grid point, then grid point, then column to column. Okay, then again this secondary beam, then again this secondary beam. So okay, this beam. So here, okay, so the columns. So here is the grid point. I think the column position has been changed. Okay, this column should be this. Draw columns. Grid point at the grid point. Okay, I'm still with the all story options. So now I'm going to draw beam. Okay, so I'm going to draw grid points. Okay, again grid point here. Okay, then grid point here again. Okay, grid point here. So here are the columns. This is the longest beam of 5.6 meter. Okay, so grid point. Now here also the grid points. Okay, and here also the grid points. Okay, here also the grid points. Okay. See, I'm deselecting by the right click of my mouse. So here also the grid point. As you can see, I'm planning according to structural plan. So okay, here also the grid point. This grid point. Okay. So 1 minute. What is the wrong here? Okay, so I am mistaken here. So I have to delete this point. This delete. So I go to draw again. Draw beam. So at this point, I'm drawing this beam. Grid point. Again the grid point at this beam. Okay. Okay. So almost it's over. Here it is the open space or the dug portion, so no slab will come here. Okay, now here is the hidden beam, but here is the portion the slab. Okay. mm, okay. 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 So okay, here also is the beam, secondary beam. Okay, secondary beam resting on this. Okay, then secondary beam. Okay, again this. Okay, now okay. So here also mistaken. This beam is continuous beam. No, this beam is resting column to column. So go to beam, go to I select a quick draw beam. No, not quick draw. So I select first option only. Okay. 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 Now this also beam. Draw beam. Draw. Okay, so this beam is resting on this beam, secondary beam. Okay. So okay, only the here is the beam. Okay. Stop here. Okay, so now only the hidden beam is remaining. No, hidden beam is remaining. No, so this beam. Okay, so this is the full beam. After that is okay. So here only the hidden beam is remaining. So I go to draw. No, sorry, I go to this properties, hidden beam. So I'm going to this hidden beam. Okay. So almost beams. Yes. So beams are completed. Beams are completed. Hidden beams. Okay. So okay. Now, so as the beams are completed, now we are going to slab sections. Okay. So now go to slab section. I go to draw. Draw. This I'm considering. Okay. So I'm considering second option. Draw rectangular slab. Okay. So here I'm considering similar storage option. So what is similar storage option? So in this lab, so as we are going to draw, so I will tell you the similar storage option. So I go to edit storage system, then modify show data. Here the one story will be the master story. So here is consider the ground floor as my master story, and rest of the stories where all the slabs are same. So I will consider here, sorry, here no, okay. So my all the stories will be similar to the ground floor now. Ground floor, ground floor. I'm okay. So ground floor, so ground floor, so ground floor. Okay, till the terrace floor, my all the floors will be similar to the ground floor because I need the slabs till then. So refresh you. Okay. So here I'm considering similar storage option and drawing the slabs. So just connect the grids to grid points as they're the rectangular slabs. We go. Okay, we go. Okay, okay. Here the hidden beam. Okay. So yeah. Okay. 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 This is the staircase area. So I am considering. Okay. Okay. And this is the slab. Okay. Okay. Here also slabs are there. Okay. This portion will be open as there is duct area. So as our slabs are completed. Okay, slab 150. Now let's see the model. So new window. See, all the slabs are completed. Go to the till the similar stories. Now we go to the extruded view. See. So okay, but okay, so okay, but in ground floor, don't need the slabs. So I'm selecting one story, then select object type, then go to floors, selected floors, again go to view, show selected objects only, and the ground floor slabs I am deleting. Okay, so we can see the ground floor slabs have been deleted. So we go to view, we go to show all objects. See, now after drawing slabs, beams, columns, the main step is now to draw the staircases. So staircase, this is a staircase which is going from here to here. Here is a MLB. So for staircase, to draw the staircase, we have to first go to edit, then go to edit storage grid system, and we have to go to modify grid system and add a reference plane. Why we have to add the reference plane? Because we have to add the landing at the mid level. So as our height is 3 meter, we are adding the reference plane of z ordinate, which is z ordinate at 1.5 meters. So if 1.5 meter show grid system, but as you can see, modify show data that my ground floor is at 1.3 meter. So I have to take the half of this. So means my 1.3 meter plus 1.5 I have to take. So 1.3 plus 1.5 will be, so it will be at 2.8 meters. So my reference plane, so I go to the modify show grid system, oh sorry, modify date. Okay, so we go to modify, so reference planes, here we have to take 2.8. Okay, okay, refresh view, modify show grid system, reference plane 2.8. Okay, refresh view. Okay, so plane has been added. Now 1 minute software. Okay, so now this plane is for the landing of the, for the landing purpose. So now I am going to the ground floor. So going to the ground floor, view, select plan view, select the ground floor, apply. Okay, so here also new window. Okay, okay, so as I have to draw the staircase first, see now I I request the students or the engineer professionals to please see the video now properly. As see, we are coming entry here, and from here. So grid line is not drawn. Okay, so now I brought the grid line. Per grid line, we have to first take the dimensions. So for dimensions, so we draw the dimension lines. So from here to here is 2.2 meter. See, 2.2 meter. So we have to draw the grid line at 1.1 meter. So I go to edit. Now after going to edit, I go to edit, then edit grid system, modify show grid data. I kept it as display as grid data as ordinate. See, this ordinates gets add up. So as grid line, so my line will be 2.2 minus 1.1. So between 6.65 and 8.85, it is the distance of almost 2 meter. So 6.65 plus 6.65. So 8.85 minus 6.65, the distance is almost 2.2 meter. And in between that 2.2 meter, I have to draw. So 8.85 or 1.1 meter means half the grid line. So 8.85 minus 1.1 meter, which is 7.75. So my point, if I add a coordinate, so here my point will be at 7.75 meter. So grid line will be, as you can see the grid line has been drawn here. So now as the grid line is drawn, so I request all to please pay attention over here. See, we are going from here, the entry is from here, and the upside we are going here from the up. So our staircase will be from this point. So from this point to this, then this, and then this. So okay, so I will show you how to draw the staircase. Firstly, as we go to plan, so now see, so now the staircase will be, our staircase will be going from here to here, see properly, here to here to here to here. So we have to draw the floor, as I have mentioned that west slab is already 150 mm I am considering. So go to draw, go to floor. Now instead of selecting the second option, now I am here selecting the first option, that draw floor. Okay, now see the property. Now I am considering similar story option. So here, as we have considered the ground floor to the terrace floor, the similar stories. So now see properly, this is the landing part, this is the landing part, this is the mid landing. Now I go, see, this is the ground floor. Now I select a point. After selecting point, my first point will be here, then my second point, I go to the reference line. My second point will be at the mid landing portion, then I'm going to here. Okay, so this will be my third point. Okay, third. Okay, and my fourth point will be at ground floor. So this portion, okay, so now my grid or my slab is completed. This will be my complete slab, as you can see. Now see, you can see here the slab has been drawn, the base slab has been drawn. Now as I have completed is okay, so my next part, so I am going here from up to here. So my next part will be from here, but it will be from the mid, so mid landing. So I come in here now. Okay, so my next point now, so my next point will be at the first floor level, this and this. Oh sorry, so I am mistaken. No, I am selecting the stories. I am going to edit and go delete. Okay, so now going again, this from this point, go to draw, go to flow, go to flow. I have selected similar stories. Now go to this point, then this. Okay, now my wet slab will be at this point. Okay, and okay, so here and so landing. Okay, so now the perfect. Okay, so now the perfect staircase has been set up, as you can see, till the terrace floor. Okay, so now we have to draw the landing. So from here I am drawing the landing to similar floors. So I go to draw, go to this, the quick draw, so go to floor. Now I'm here drawing the floor slabs. Okay, so the landing has been drawn here. And here the middle landing should be, go to set plan view, go to reference plane, apply. Okay, here the middle landing should be there. Okay, so as we can see, the middle landing has been drawn. Here the beam should be drawn. So the beam is 230 by, which is the mid landing beam. Okay, go to 3D view, go to the extruded view. See, as we can see, the beams have been drawn. Okay, the beam has been drawn. So as you can see that almost the modeling of staircase and slabs and floors and beams and columns have been completed. Now as we can see that the still this terrace floor, we had the staircase, but now the columns, beams and yes, columns and frame beams we have to delete from the headroom slab. As we can see, this we have selected first all story options, so the beams and columns have also been modeled over there. So now we have to delete and just kept the required part for us to for analysis of headroom. So we are going to view, set plan view, then going to headroom, apply. Okay, so as the headroom, we just want, we have selected the one story option. Now we just want this part of staircase for a slab purpose. So now I am deleting the rest of the part. Go to select, go to edit, go to delete. Okay, go to select, go to edit, go to delete. Okay, go to select, go to edit, go to delete. Okay, so okay, and remaining part, if there is any remaining, no, no part is remaining. So, okay, so now our headroom has also been modeled. So just modeling of the slab, go to rectangle slab. Okay, okay, one story. Okay, see, as we can see, a model, go to the extruded view. See, so model, our model has almost completed, means completed. Okay, so the modeling part of our G+4 structure building has been completed. See, as you can see, slabs, beams, columns, all are completed. So I think this is enough for the first part of the video. See, in the first part of the video, we have enter the basic data, then define the material properties, we have defined the section properties, then define the diaphragms, and we have completed drawing of the model. So just if we check the model, just go to analysis, keep this as 10 mm, joint tolerance. So meshing part, we have to do the meshing later. Okay, the model is checked. See, as you can see, the model has been completed. So now, as our model has been completed, in the next part of the video, we will try to complete the, we have to first assign the load conditions, or sorry, support conditions, releases to the beam and diaphragms. Then we have to do the load calculations, then define the load patterns, then assign the loads and analyze the structure. So I hope this video finds you helpful, and the engineering professionals or the people who want to learn the ETABS, this video is for the beginners, so I think it is helpful for the people. Thank you.